We're fine?
Yes, we can hear you and see your slides.
Okay. Yeah, I think we jumped right into computational storage and didn't give you guys any, in case you hadn't heard the term, any clue what it is. And both ScaleFlux and in the Samsung case, we're talking computational storage drives where we've added some compute capabilities directly into the SSD itself. So not as a separate device or a separate add-in card or anything to put into the system, but just integrated directly into that SSD form factor. So yeah, as you mentioned, I'm going to go through just a couple of use cases where we have proof of concepts going on more edge deployments. We do also have deployments going in core data centers and enterprise environments, but here we're going to focus on a couple of newer cases on the edge. So the first one here is for deployment in a retail chain where they've got hundreds and even thousands of facilities nationwide and multinational. And they've got these essential applications that need to run on site and have very tight latency requirements. Mentioned there's lots and lots of locations. In these locations, though, they don't have IT staff, right? I mean, this is not a data center where you got professionals who know how to run everything. This is sitting in a closet in the back office somewhere. So you don't have that real on-site data center. You don't have the environmental controls. You don't have the knowledge base on site to really manage a complex solution. So as a part of that, you also have the challenge of you need to be able to manage this remotely through a centralized software suite. In these environments, it is a very, very power and thermal sensitive environment because, as mentioned, you don't have the controls like you do in your data center. And it's also very cost sensitive because they're deploying thousands of these across lots of locations, and if there are failures, they want to be able to replace them cheaply. So the solution that we have out there in conjunction with Scale Computing, no relation between ScaleFlux and Scale Computing other than the accidental similarity in the name, where we have the computational storage drives, and they have developed this low overhead edge computing software. And so with the combination here, what we're able to do is meet these latency requirements, add functionality into these very small form factor, very low cost form factor systems without expanding the cost, right? So the CSDs add on to the functionality that you can get into these very small form factor, very low power systems by putting some of these functions into hardware engines. So in our case, what we've done is put compression directly in a hardware engine in the SSD so that you can store more data per gigabyte of flash that you're putting into the drive. And then improving the thermal management by taking that function, first off, putting it into a hardware engine that consumes less power. And then secondly, removing it from the CPU complex. So now you're distributing the power across multiple components to help you with avoid hotspots and with that cooling. And then, as I mentioned at the start, we're not adding any physical footprint. So everything is integrated right into the SSD that was already going to be a part of the server. So you didn't have to put in an extra add-in card or other components into your server to provide the functionality. The software that comes from Scale Computing addresses the system constraints and management. What they've done is develop a hyperconverged infrastructure capability that can be deployed in these edge systems where there is a very small memory footprint and you're able to use lower power, lower cost CPUs. And they still enable the centralized management across thousands of deployments. Lost track of I can't see the chat, so speak up if there's questions on that. The second example here is little bit different where we're using computational storage in conjunction with software to help address data security. So here, what we see is that there's lots of data that's generated across these tens or hundreds, thousands of edge locations, or even within the data center. Um, this would apply, and you need to protect against misuse of that data. So we're all familiar with, we typically encrypt the data, but then transferring the data back to the cloud does open up opportunities for intrusion, right? Each time we move the data off of its media, there is that opportunity of somebody, a man in the middle, intercepting the data and figuring out what something to do with it. Or even if it's not a malicious actor from outside, you transfer the data over there, say you're transferring an entire record for a purchase. And you were trying to do a query that was just related to a couple of the fields, but you had to transfer the whole data set. That does open up the opportunity for unintended inferencing and model training, where they're leveraging other fields to do additional analytics that may not have been approved. So, here again, we're looking at the computational storage drive combined with third-party software. In this case, Protopia is the company that has developed this data transformation application that can be run in the low power cores within the drive. And so with this combination, what happens is rather than transferring the raw data from the drive, the original data stays in the drive and a representation of the data is transferred. The Protopia software does a stochastic transformation of the data to help improve the security. And then the CSDs running this data transformation directly in the drive helps protect the original data. So, you never had the original data leave, so there's nobody in the middle can interact or grab it and do something with it. And then that transformation helps to minimize that potential that somebody can misuse the data. The it's the way they described it, and you'd have to contact the Protopia guys to get a much deeper description. But they, in that database example that I gave, if there's a query that's being run that is looking at, say, name and address, but not social security number and other things, that, or credit card number that might have been part of the file, they're transforming the data and such that the query can really only read the fields that were intended. So the extra fields are scrambled and can't be misused to do those unintended inferencing and model trainings. So these are just two different ways of potentially leveraging that, adding some capability into the drive itself to help improve or help solve problems out there around data security and deploying systems on the edge and achieving your overall cost and performance requirements. So if there
Cool.
were any questions, let me know.
Thank you, JB. I don't have any questions queued up. We do have time for people over the next 20 or 30 minutes if people want to ask some questions as well of Mayank or JB. Okay. Thank you very much.